Chapter 4 is going to be all about congruence and mostly about triangles, except that at the beginning here, we're going to talk about congruence in general with polygons. So first of all, the definition. So the definition of congruence for polygons is, and I don't know if I don't think I ever showed you that abbreviation. That abbreviation is if and only if. That's not a typo. That's if and only if. So remember, that's a biconditional statement. So definitions go both ways. So if two polygons are congruent, that means that there is a way to match the vertices. Okay, it's called correspondence. There's a correspondence between vertices. A correspondence between the vertices such that all corresponding sides and angles are congruent. Okay, so those of you who just joined me, this is lesson 4.1, and everybody's going to be submitting this to classwork at the end of class. So that's just saying that when you have two congruent polygons, that means you could basically take one of them and rotate, flip it around, and put it directly on top of the other one. And we can form what's called a congruence statement. Okay, so a congruence statement means you're going to write a statement that says how the vertices match up. So you're going to notice on the picture here, we've got angle C and R matched up, and we have angle B with the double marks and, and Q matched up. And then we have A and P with the 3 marks matched up. So if I write triangle, and it doesn't matter how I name the first one, I can call it anything I want, CBA, ABC, ACB, whatever. I'm going to go ahead and do it CBA just because I'm going from a single to a double to a triple marked angle. So the vertex at C has to match. I'm going to highlight these. Oops. C matches with R, right? That means wherever C is in the name has to match with vertex R. So triangle R, and then B is 2 marks is matched with Q. So that means Q should be in the second spot. Okay, so C and R match up, B and Q match up. And the third vertices should match up, and the ones that are marked with 3 vertices are A and P. Okay, that's called a congruence statement. So a congruent statement tells you how the vertices match up. Sometimes instead of giving you a picture, they'll give you the congruent statement and expect you to understand that that means that C and R go together and B and Q go together, etc. Now it says identify all pairs of congruent corresponding parts. So that means that since they're triangles, there will be 3 pairs of congruent angles. So angle C is congruent to angle R. Angle B is congruent to angle Q, and angle A is congruent to angle P. When you name the segments, it's really important that you pay attention to the order. So if I were to say segment CB, for example, well, CB goes from C to B. So the vertices in the same spots would be R and Q. Now you can also get that off of the picture. So you can look at the picture and say, okay, if we went from C to B, we're going from single to double marked angle. That would have to be the same thing in the other triangle, from the single to the double marked angle, from the green to the pink, and then the green to the pink. Okay, the order matters. When it asks you to identify the corresponding parts, if you put QR here, even though it's the same segment, that's going to be considered wrong. Okay, everything with congruence of polygons requires you to pay attention to how the vertices match up. So CB and RQ would go together, and BA would go with QP, and then CA would go with RP. Okay, so again, I'm looking at the congruent statement here, and I'm just saying B to A would be the same as Q to P, and that C to A is the same as R to P. Now, would it be okay to say like segment AC, for example? So that's fine as long as you have the correct order. If I go from A to C, the other way around, we go from A back to C, we'd have to go from P back to R. So there's nothing magical about the way you state the first pair of segments, the first segment, but the second one in the pair has to match the order of the first one. So again, I can look at it and say CA, for example, goes from the single to the triple marked, and then that would have to be R to P. So green to blue, and then green to blue. If you decide to go the other way around, we go from blue to green, then you have to go blue to green. So everything about congruence means that you've got to match the vertices up. Okay, second example. So we have quadrilaterals this time, and notice that they've given you a congruent statement. So they're telling you how the vertices match. Now, there's kind of two ways you can show this. You can either say, since D is in the first spot, and so is K, that means D goes with K, and kind of mark them. E goes with L, etc., all the way around. Or when you're using your iPad, you can just use colors like I did up above. Sometimes it gets kind of crazy when there's four vertices and you're trying to put 4 on one and 3 on another, and it starts looking like hard to even see what's happening. So you could either use colors like I did and match D with K like I did on the previous one, or if you don't have colors like on a quiz or a test, if maybe you're not using colors, you can say, all right, D matches with K. I'm going to circle those. And then E and L go together. So I'm going to put little quadrilaterals around them. And F and M, I'm going to put triangles. Okay, so just some kind of symbol that shows how they match up. And then G and N. So I'm going to do a little like cloud thing here. Okay, now again, you can mark them with congruences, or you can use colors also. This is just a way to show it when you don't have maybe different colors to be able to distinguish them easily. All right, find the value of X. So the expression for X is right here on segment NM. So for part A, I want to know what segment is congruent to segment NM. You can either get that from the picture, or you can get that from the congruent statement. Okay. Grant, what segment is congruent to segment NM?
FG.
Okay, so if we go N to M, then your order needs to be
OGF.
G to F. Yeah, so NM and segment GF. So again, you can look at it on here as saying that NM is that segment right there. It's going to have to match. If we go from N to M, we're going from the little cloud to the triangle. So on the other one, the little cloud to the triangle would be GF. So that means that those two segments have to match up. So their lengths are the same. So we know that 5x plus 2 has to equal 12. So 5x is 10, x is 2. Now again, you can get it from either the correspondence, you can get from either the congruent statement or from the picture. So for finding y, okay, so y is, let's see, 5y plus 6 is angle L. Okay. When you use L for a vertex, you have to be a little bit careful. It doesn't end up looking like that, because then somebody reading it's like, what does that even say? Okay, angle L. Kendall, can you tell me what vertex is, which angle is going to be congruent to angle L? Which vertex matches up?
E.
E. So on the congruent statement, L and E match up, or on the picture, the way that we've marked them, we can see that L and E would have to go together. Okay, and E is 111. That means that since the corresponding angles are congruent, we'd say 5y plus 6 has to equal 111. So 5y is 105, and y is 21. Okay, let me pause for a second. Any questions? One thing I'm going to caution you about, don't assume that the pictures are drawn to scale. So don't be sitting there trying to like rotate it or like flip it over, you know, in your head and try to like see how they match up. Literally just use the vertices that they've given you, and then you don't have to be trying to, you know, figure out how things match up, because they may not draw it to scale. Like they might say, here's a triangle and here's a triangle, and then they give you a congruent statement and you can even tell really how they're supposed to go based on the picture. Okay. Next idea. Next idea is third angles theorem. Okay, this is what the third angles theorem says. If you have two triangles, okay, you're given two triangles and two pairs of congruent angles. So see how B and E are marked congruent and A and D are marked congruent. It's called the third angles theorem because if angle A is congruent to angle D, and angle B is congruent to angle E, then what should go in the blank there? It's called the third angles theorem. Jake, what should it say?
C. Oh.
Jake, what should it say?
I didn't know you said my name. My fault. It should be C is congruent to F.
Angle C is congruent to angle F. Now, this is saying given two triangles and two pairs of congruent angles, then the third angles are congruent. That's why it's called third angles theorem. Now, we need to be a little bit careful about this. So let's say we have two triangles. I'm going to draw a triangle here. Do you remember what you call a triangle that has three different side lengths? So it's not equilateral, it's not isosceles, it's what?
Isotope.
It's what?
Or
It starts with an S. Anybody remember that?
Scaly.
Scalene. Thanks, Ryan. So let's say we have a triangle where we've got three known angle measures. Okay, I'm going to just make a copy of that. So I'm drawing a scalene one just so we don't have to worry about, like, you know, can we tell that two sides look the same or not? So let's say we have two triangles like that. All that I'm telling you is that all three angle pairs match up to be the same. Is it true that the triangles are congruent?
Yeah.
Okay, Michael said yeah. So those triangles that I drew there are congruent. What if I do this? Are those triangles congruent? Or I could do, right? Those triangles are not congruent because why? Because I can still check. Rotate it a tad. I can still check those angles match up. Right? Why are the triangles not congruent? Kara, why are the triangles not congruent?
Is it because like the segments would be different lengths?
Yeah, the sides would be different lengths. So you have to be careful, because if I give you all three pairs of congruent angles, but you don't know any side lengths, the triangles are not necessarily congruent. Maybe they are, but they don't necessarily have to be congruent. Okay, so if you know all pairs of angles in two triangles are congruent, then the triangles are not necessarily congruent. Like maybe they are, but maybe they're not. So the third angles theorem does not tell you whether the triangles are congruent. Okay, so be careful, because the third angles theorem just says you have two triangles and two pairs of congruent angles. That makes the third angles congruent, so we would know that those are the same. However, the triangles are not necessarily congruent. Okay, so be careful with the third angles theorem, because third angles theorem is not a way to prove that triangles are congruent. So what we know about those triangles is that they will be similar. So this is something we'll talk about a lot in chapter 7, I think it is, in second semester. So these triangles are similar. So similar means they have the same shape, but they might be different sizes. Okay, they are similar because they have the same shape, but possibly different sizes. So the side lengths are what we call proportional. That means that, like the one that I drew here, maybe like each side is half as long. I'll shrink it down a teeny bit more. Maybe each side is like half as long as the side in the original triangle. So when you match up the side lengths, that's a 2-to-1 ratio. That will make the triangles similar. They'll keep the same shape, but they don't necessarily have to have the same side lengths. Okay, so if you only know angle measures, be careful that you don't assume that that makes the triangles congruent. Again, similar is going to be something we talk about next semester. Okay, find the value of x. Name the postulates and theorems that you use. So I'm just going to go ahead and say I can take that 54 degrees and pull it over to there. Okay, and I can take the 67 and I can pull it over here. And then 4x minus 5, you know. So what theorem are we using? What equation will we have? It's our equation.
Wait, can we use the triangle?
Say that again, Kara.
Could we use the triangle?
So your equation would be triangle angle sum theorem. Your equation would be 67, 54, and 4x minus 5 equals 180. So let's see, 67 and 54 is 121. And then minus 5 is 1. It is something wrong. Okay, minus 5 is 116. So 4x plus 116 equals 180. So 4x is 64. X would be 16. Now, we didn't even actually have to use that the triangles were congruent. Like, it didn't even tell you the triangles are congruent. What we know is that the angle pairs have to match up. So those triangles might just be similar. They may not even be congruent. All right, next problem. Decide whether the triangles are congruent. Now, by definition, that means you have to know all pairs of angles match up to be the same, and all pairs of sides match up to be the same. So you can see on the picture that the vertical angles would be congruent. So there we're using vertical angles congruent. Okay, and then how would we know that these two have to be the same? What's the reason that those will be congruent?
The third angles theorem.
Third angles theorem, good. So because, I didn't mention this a minute ago, but third angles theorem makes sense because they have to all add up to 180 in both triangles, right? So when you take away the same amount from the two triangles, the leftovers, of course, have to be the same. Okay, so we were shown on the diagram that all the pairs of sides match up, right? We get the 1, 2, and 3 marks. And then for our angles, the given angles, the vertical angles, and the third angles makes all the triangles congruent. So yes, the triangles are congruent. We're going to write a congruent statement. If I said FED for the triangle on the left, that would be single, double, triple marked, right? What is the correspondence for the other triangle? So FED and what? Max, can you give me the other triangle's name? FED, so I'm going from the single to the double to the 81-degree angle. What would be the correspondence in the other one?
Would it be FHG?
So E was the one that had the double mark, so that means that the second letter needs to be what?
Oh, it would be FGH.
GH. And again, with congruence, it's super important that you keep the order matched up. Okay, so that's your congruent statement, and it would be because all pairs of corresponding sides and angles are congruent. All pairs of corresponding sides and angles are congruent. That's the definition of congruent polygons. You can match up the vertices so that all the sides that match up are the same length and all the angles that match up are the same angle measure. All right, for our next one, we have 95 degrees is given. Is there anything that we could mark congruent that's not currently marked? Anything that you could mark congruent that's not currently marked?
The middle angles that are vertical.
Okay, vertical angles have to be the same.
Diamond, you are so loud.
Say again.
I wasn't even trying to be loud.
You just were again.
I did that one on purpose.
Derbla, is there anything else that is not marked currently that we could mark congruent?
We could mark the remaining angles congruent.
Okay, so third angles theorem would mean that we could mark those angles congruent. You can either write the word third or you can write it like that. Okay, but again, third angles theorem tells you that in two triangles, if you know two pairs of angles that are congruent, then the third angles will be congruent. Okay, are those triangles congruent? That's for anybody. Are those triangles congruent?
No.
Why not, Jerome?
Because the sides, like where the 95, like where that angle is, those sides, they don't match.
Yeah.
The one on the left is smaller.
The sides are, right? I've kind of drawn it so that it didn't look like the triangles were congruent. But even if I drew it so they looked congruent, if you don't know any side lengths, you will not be able to say if the triangles are congruent. Okay, so it's not really that we know that they're not congruent, just we can't tell if they are. Since we don't know any side lengths, we cannot determine, can't tell whether the triangles are congruent. However, we can say that they're what?
Similar.
We can say the triangles are similar. So if you know all the angle measures match up, but you can't determine any side lengths, then that still will make the triangle similar. They'll have the same shape, but they might be different sizes. Okay, we're going to hold on to this until next time. I don't think you really need that for the homework anyway. Okay, the homework is going to be problems out of the book. It's posted in Schoology. And then please make sure that you submit these notes to, I think it's classwork number 11. I'm not 100% sure about the number. Okay, but it'll be the lesson 4 one.